In this video we look at the fetch, decode, execute cycle in detail and the effect that it has on the registers. When an instruction is to be fetched, the program counter contains the address of the next instruction. So in this case the next instruction is at address 0000. So the program counter has 0000 stored inside it. This address is then copied into the memory address register. The address is then sent along the address bus, where it waits to receive a signal on the control bus. Because we want to read the value that's in address 0000, the control unit sends a signal on the control bus to the memory controller to say memory read. The contents in address 0000 can now be transferred along the data bus. Because what we were fetching was an instruction, the value from the RAM now goes into the current instruction register. At this point the instruction has been fetched, so we can now increment the program counter to be ready to fetch the next instruction. So here the program counter now contains the value 1. It's been incremented by 1. The instruction in the current instruction register is now decoded by the decode unit. You'll notice there are two pieces of information in here. One is the opcode, or the operation code, or the command. The other is known as the operand, the address or the data for the opcode to use. 0101, if we look in the list of instructions that the processor understands, we can see that that means a load. 0101 means load, and the address 0101. So we've got to go back to the memory, we've got to find what's in 0101 and return it. Because the data we need is at address 0101, we have to send 0101 to the memory address register. You'll notice at this point that the program counter and the memory address register contain different values. That's because the program counter is storing the address of the next instruction after this one has finished execution, and the memory address register is storing the address of the data that we need in order to complete the execution of this instruction. The address can now be sent down the address bus, where we'll wait again for a control signal on the control bus to say we want to read the memory. So here is address 0101 in the RAM, and that is going to be sent down the data bus. Notice how the memory data register now contains the value that was in RAM, ready to be passed to the accumulator. And here the value is now in the accumulator and we're ready to fetch the next instruction. So this is the state of the registers after one cycle. A useful exercise from this point is to follow the pattern again: fetch, decode, execute, fetching the next instruction, which is at address 0001, and see what effect the whole program has on the contents of the registers. Before we leave this illustration, let's just consider what happens in a program branch. Now, a program branch can happen for a variety of reasons. Maybe there's an if statement, maybe there's a loop, maybe there's a function or a procedure call. There are lots of reasons why we may not be executing the next instruction pointed to by the program counter. So let's consider this particular example. Here in the current instruction register, we have the value 0110. So that opcode means branch always. So we have to change what's in the program counter to be what's in the operand, in this case 1001. So you see in this example the program counter is not incremented, but it's had its value changed to what was in the operand. Now you may be wondering, if the program counter is changed because of a function call, for example, how does it ever remember how to get back to where it was in the program before? Well, For this you need a data structure called a stack, and we'll see how that works another time.